Okay, so let's continue our discussion on clamper circuits. So as you can see here, uh, uh, clamper circuit. To construct a clamper circuit, I said this clamper circuit is a wave shaping circuit, which is used to move a signal, shift a signal upward by some DC value. We call it a positive clamper, or shift the signal downward by some DC value. We call it negative clamper circuit. So this clamper circuit constructed from these three components. We need what? As you can see on the slide, a diode, resistor, and capacitor. Sometimes, if you need to shift signal to some other level, we need some battery. We call it biased. If you connect additional battery, we call it a biased clamper. We'll come to that later. But the three basic components of any clamper circuits are diode, a capacitor, and a resistor. So what are the important points you have to know about clamper? As you can see on the slide, here clampers does not change the waveform. So the level, the DC or the average level only either shift upward or downward. That's the first point. Second, there is no change on the peak-to-peak value or RMS value. When you clamp a signal, the peak-to-peak, the range from maximum to minimum, is not changed. The signal as it is shifted or upward or downward. But the peak-to-peak voltage and the RMS voltage will not be affected by a clamper circuit. That's the second point you have to know. Okay, if you have a sinusoidal signal, peak-to-peak voltage 20. If you shift it upward or downward, the peak-to-peak voltage remains the same. Even the RMS root mean square value remains the same. The waveform remains the same, no change. The only change to this signal by clamper circuit is the DC level. The average value of the signal will be either increased or decreased. That is the second point we have to know. Third point, there will be a change. You can see in the slide, there will be a change in the what? Peak value, not peak to peak. Let's go back to our slide here. When you see this signal, what is the peak voltage? 10 voltage, right? 10 volts. After clamping, this peak value, the maximum value, shifted here by 10 volts. So it becomes what? 20 volts. So peak value changes from 10 to 20. I'm not saying peak to peak. Peak to peak remains the same. Peak to peak means from here up to here. This range from maximum to minimum, can you hear me? My voice, is it okay?
Yes.
Okay. So we are discussing the important points about clamper circuits. So the shape, the waveform remains the same. The DC level will be shifted upward or downward. That's the first point. There will be no change on the peak-to-peak and RMS value. And the third point is the peak value and the DC average value will be changed. So here, as I said, peak value changes from 10 volt up to 20 volt when you clamp it on the positive side. On the negative clamper, input voltage peak volt 10. Now the maximum becomes 0 volt. You see, because the signal is clamped downward. Here, the negative maximum was minus 10 volts, the input. After clamping upward, it goes to 0 volt. When you clamp it, shift downward, this minus 10 becomes minus 20. Okay, so peak values will change when you clamp a signal, but peak to peak, the range from maximum to minimum, this difference remains the same. That is important about clamper circuit. The three important points about clamper circuit. Okay, so what are the type of clamper circuits? Positive clamper, negative clamper, as we have discussed. We'll discuss one by one. And clamper with biasing voltage. If you add a battery, additional battery, again, to increase the DC shift by more voltage, we need to add battery, we call it biasing voltage, clamper with biasing voltage. Those three types of clamper circuits: positive, negative clamper, and clamper with biasing circuits. Okay, so now let's see first the clamper circuit. As I said before, clamper circuit constructed from what? It's constructed from capacitor, a diode, and a resistor. So we apply here our input signal. Here we get our output signal. Okay, so this is input signal applied. This is output signal. So this is a positive clamper. This is the N side of the diode. This is the P side. Now, what will happen during the positive half cycle? Let's see how this clamper circuit, we call it a positive clamper. As you compare input and output, what will happen? What will happen? This signal is shifted what? Upward, because we are designing, we are constructing here a positive clamper. So Vm becomes 2 Vm. Here minus Vm becomes now 0. Okay, because the whole signal is shifted upward by Vm value. Using this simple clamper circuit, it consists of capacitor, diode, and resistor. Now, let's see how the operation of this circuit, how it works. This is our circuit. During the positive half cycle, when input is positive, so which means this is positive, when input is positive here, what will happen to the diode? Diode, this is N side, this is P side, right? So what will happen to the diode? Reverse biased or forward biased? Positive with N side. It will be reverse biased. Reverse biased means, as you can see here, the diode is off, right? The diode is off because it is reverse biased. So when it is off, what will happen? The output will be the voltage, input voltage, plus the voltage. Here is the capacitor. Capacitor now charges when, look here, when the diode is off, the diode is off. Why? Because this is input is positive. In the positive half cycle, positive connected to the N side of the diode, reverse. This diode will be reverse. It will be what? Reverse biased, right? Reverse biased means it is off. As you can see in this diagram, it is off. So now let's say we apply here 10 volt peak sinusoidal signal as input. So in this positive half cycle, this diode is off, right? When it is off, what will be the output voltage here? At this point, we have V out. V out will be the input voltage plus the voltage stored in the capacitor. Capacitor now charges. Charges from where? From the input voltage. It charges through this path. It charges through this path. So it stores. The capacitor in this case is used as a battery. Capacitor, as you know, it stores charges, right? So in this case, it charges and it stores the maximum voltage 10 volts, right? So what will be the peak-to-peak voltage at the output? The out will be the voltage input plus the voltage stored in the capacitor. What is the input voltage? 10, right? So what will be here? 10 voltage from the input plus voltage is also stored some charges. How much? It stores to the maximum 10 volts. So 10 plus 10 will be 20 volts. So 20 volts at the maximum, right? When it is a positive, when input is positive, the diode is off, capacitor is charged to the full, the maximum charge, 10 volts. This 10 volts will be charged, stored here. So output voltage will be, you see here, this input voltage connected in series with this capacitor, right? So you have to add these two to get the output voltage. Output follows the input because there is no diode now. Diode is off. When the diode is off, output is equal to input plus the voltage stored in the capacitor. Now, I have to, okay. If you have any question, let me check first in the chat. Jasmine, I cannot hear you. You can unmute your. Okay, let's continue. We are discussing a positive clamper circuit, a wave shaping circuit. I'm muting the background. Okay. So we are discussing positive clamper wave shaping circuit, which is used to shift a signal upward. So we are discussing how it works. So let me repeat again. Okay. So we are applying a sinusoidal signal to this clamper circuit. As you can see here, the diode is connected inside here and P side here. This is our capacitor, which is charged by this input. Okay. Now, what will happen when input is positive? So the first case, during first positive half cycle, what will happen to the diode? Because when this is positive connected to N side, the diode will be reverse biased, right? Reverse biased, it is off. We are considering ideal diode. It is off here, you can see. So now, the capacitor charges through this path. It charges through the resistor from the source. Okay, charges up to what? Let's say maximum peak voltage, we have 10 volts sinusoidal up to -10. So it's positive cycle. It capacitor charges store to the maximum 10 volt here. So we store 10 volts here. What will be the output voltage here? V out. That is the question. Output of the this clamper circuit. Output will be, this is off, the diode is off because it is reverse biased. So you see here, input connected through the capacitor to the output. Start from here, go to the capacitor to the output. So how many voltage we have here? One input, one capacitor. How much input voltage? 10 volt. How much voltage stores the capacitor? 10 volt. 10 plus 10, we have here 20 volt output. You see here, the peak value 10 shifted to 20 volt because of the capacitor here. Because the capacitor store additional charge for us. So the signal is clamped upward by 10 volts, which is stored in the capacitor. Now, what will happen when the input is negative half cycle? What will happen when input is negative? So this will be negative. So negative connected to what? N side. So negative to negative, what will be the diode? Diode will be forward biased. When it is forward biased, what will happen? It is on. When it is reverse biased, we have said it is off. When it is forward biased, now it is on. So what will be the output now? Here. The output voltage becomes 0 volt. Why? Because it is shorted here. Because the diode is now on, the output here directly connected to the ground. It is shorted. So what will be the output voltage? 0 volt. So as you can see here, the negative half cycle, it was minus 10 previously. Now, because the diode is shorted, this peak value is shifted here, okay, from minus 10 to 0. This is how a positive clamper circuit works. This is my simulation. You can check in your TINA software. Also try to construct this clamper circuit. Connect 100 microfarad capacitor, diode, negative side on the upside. This is a resistor. Connect one pin here, another pin here for the oscilloscope. So you can check input and output waveform. The output will be shifted upward because of these positive clamper circuits. Okay, any question?
Negative.
Too much noise, so you can write your question on the chat. Yeah, if you have any question. You can write your questions on the group chat on the left. You can turn on your chat. No question. Okay, so let's continue to negative clamper circuits. Okay, so what's the difference between negative clamper and positive clamper? Just on the positive clamper, the diode N side is here, P side is here. On the Okay, so just flip the diode on the negative clamper. The P side now is here, N side here. This is a negative clamper circuit. Previously, for positive clamper, this is N side, this is P side. Now flip it, it becomes negative clamper. Again, we have a capacitor here and our resistor here. In this case, let's check by applying a square waveform. You can apply any waveform, no problem, to clampers. The waveform, if you apply square waveform, the output is also square waveform. So what is the difference you see between input signal and output signal? This square waveform shifted downward by this negative clamper. Because it is negative clamper, this square waveform, what, let's say we have 10 volt here and minus 10 volt here. That's square waveform input signal. So what is the peak to peak? Peak to peak voltage is 20. Okay, peak to peak voltage is 20. Similarly here, what is the maximum? In this case, this is 0. Minimum minus 20. So again, peak to peak will be the same. Peak to peak will be 20 volt. Peak to peak again is 20 volt. No change on the peak to peak because it is a clamper circuit. The waveform also the same. Square waveform, square waveform. But the signal is shifted downward because here we have a negative clamper circuit. Okay, so how it works? Let's see what will happen when input is positive. During the positive half cycle, when input is positive, this is P side of the diode, this is what? N side. So what will happen to the diode? Positive with P side, it will be forward biased. So forward biased means the diode is on. When it is on, what will be the output? Output now directly shorted here, right? It is directly connected to ground. So when this is positive, our output is at 0. You see, it is 0 level. Previously, input is at 10 volt. Now it becomes 0 volt because the diode is shorted, right? This is now when the input is negative, the diode will be, what will happen to the diode? When input is negative here, the negative half cycle, so this is negative, this is positive. Now negative connected to P side, so it will be reverse biased. Reverse biased means our diode is off. As you can see here, it is off. When it is off, now output follows the input through this path, right? So what will be the output voltage here? Output voltage is equal to the voltage input, which is minus 10 volt, right? Minus 10 volt because it is negative, plus the voltage stored in the capacitor. In this case, the capacitor is charged in the opposite direction. This is how the capacitor charges. Previously, in positive clamper, we have seen the charging path. Now it's charged this way. So the voltage stored in the capacitor again is minus 10 volt. So what will be the output? Minus 10 from the input, minus 10 from the capacitor. So it will be minus 20 volt. Okay. So as you can see here, on the when input is negative 10, after negative clamp, it goes down to minus 20 volts. Minus 10 volt from the input, minus 10 volt from where? From the charge stored in the capacitor. So this is how negative and positive clamper circuits are working. If you have any questions,